Welcome back, class, and today we're going to talk about part 2 of this topic. So in part 1, we looked at melting, and in part 2, we're going to talk about the reverse process of melting, which is solidification. So, like I said, the reverse process of melting is called solidification or freezing. So solidification or freezing is a process whereby the energy transfer changes the state of a substance from liquid to solid and at a constant temperature, just like melting. If we observe the temperature of solidifying or freezing substances, for example, liquid naphthalene, we will see a pattern shown below. So if you draw a graph of temperature against time for freezing substances, it will show this sort of pattern. So any freezing substance, if you plot a graph of temperature against time, it will always show this type of curve. And for this graph, we are using naphthalene, which is a chemical, to show what happens to its temperature. So this graph is the opposite of the graph that you learned in part 1. This graph is known as the cooling curve because you can see it's a curve and it goes downwards, the temperature goes down. So it's cooling. From the graph, you should see that the process of solidification or freezing is also at a fixed temperature, just like melting. And from this graph, you can tell that the freezing point of naphthalene is 78 degrees Celsius. Okay, so let me explain what is going on in this graph. So at first, the substance, in this case naphthalene, starts at a certain temperature. Let's give this a temperature of 100 degrees Celsius. And in the beginning, the naphthalene is liquid, and then we cool it down. So you can see when we cool it down, the temperature drops, but it's still a liquid. Once the naphthalene has reached 78 degrees Celsius, you can see we are still cooling it down. It's still losing heat energy, but the temperature remains constant. And during this period here, the naphthalene begins to freeze. So the liquid before now is starting to freeze and become solid. So now during this period of solidification, we have a mixture of liquid and solid. But once the solidification has completed, or once freezing has completed, once everything has become solid, which is at this point here, now you have only solid remaining, then the temperature begins to drop. So in the beginning, you have liquid, and then when it's solidifying or when it's freezing, you have a mixture of solid and liquid. Once that has ended, you only have solid remaining. In fact, the freezing point and melting point of a substance is the same. So naphthalene's melting point is also 78 degrees Celsius. So that's a very important point to know. The freezing point and the melting point is usually the same temperature. So for example, water has a melting point of 0 degrees Celsius. It also has a freezing point of 0 degrees Celsius. Same thing here. Naphthalene has a freezing point of 78 degrees Celsius. It also has a melting point of the same temperature. So the constant temperature at which a substance freezes or solidifies is called the freezing point. Now we're going to talk about the factors affecting the melting point or factors affecting the freezing point. These two are basically the same. So if you add impurities in a substance, it can lower the substance melting point. For example, water has a melting point of 0 degrees Celsius, but if you add salt to pure water, that's going to lower its melting point. How is this useful? In cold countries during winter, ice can take form on pathways and on the road. It can be very slippery and dangerous. To melt the ice, people usually spread salt on the ground. The salt lowers the melting point of ice so that it becomes liquid easier. The second is the effect of pressure on the melting point or the freezing point. So at higher pressures, the melting point of a substance is lower. At lower pressures, the melting point of a substance is higher. So how is this useful? If you skate on ice, you will notice that the ice floor will melt even when it is cold. This is due to the fact that the blades of the ice, so it's very sharp. It has a lot of pressure when you exert it on the ice floor. So sharp objects have small surface area and therefore it gives a high pressure. Now because of this high pressure, it decreases the ice's melting point and the ice becomes water easier, causing it to melt. And that's pretty much it for part 2 for solidification. For your exam, make sure you remember the definition of solidification, and also make sure you remember how to find the freezing point of a substance from a cooling curve, this graph here. You can find the freezing point when the graph becomes constant, or when the graph becomes a straight horizontal line. So this horizontal line here, this will tell you where the freezing point or solidification point is for that substance. And also make sure you understand what is going on with this graph. In the beginning, there's only liquid. When the substance is solidifying or freezing, you have a mixture of liquid and solid. And then after that's done, you only have solid remaining. And then you make sure you know the two factors that affect the melting point or freezing point of a substance. The first one is impurities. So adding impurities can lower the substance melting point. And the second one is pressure. So higher pressure, melting point is lower. Lower pressure, melting point is higher. And then for part 3, we're going to talk about the next two processes, boiling and condensation.